Sorry about that. I'm having a little bit of technical difficulty with my toolbars. So I wanted to hit record. All right, so back to here, 21 like Mozart and Haydn, 14 like Beethoven and Haydn. Eight like all three. Okay, so that's the information we have. So I'm now going to draw a Venn diagram. So we've got a box here. I'm going to put 3 interlocking circles. So Venn diagram with 3 sets. We'll divide up into 8 regions. And so we want to put the number that would belong to each region. And I'm going to name the sets as they are named on my math lab. So this will be Mozart, this will be Beethoven, and this will be Haydn. All right. So when we start this process, remember we always start where all 3 overlap. So somewhere in this way we have that information, and right here it says 8 like all 3. So that tells me we have to have 8 right there. Okay. Now we'll spiral out. Doesn't matter which one of these we hit, but we're given right here everything we need for all 3 of these. So I'll just start here and work my way down. So it says 15 like Mozart and Beethoven. So that would be right here. Now, since it's 15 that have to comprise this entire region, we have accounted for 8 of them. So 15 minus 8 is 7. Or 7 plus 8 is 15, but now that would give you my 15 that like both Mozart and Beethoven. Moving to here, Mozart and Haydn, that would be this region right here. And it says there's 21, so 21 minus 8 is 13. So I'd have to have 13 here to get my total of 21. And then 14 like Beethoven and Haydn, which is here. So if I've got 8, I would need 6 more for my total of 14. All right, so from there, I'll just go to each one of these. I'll start here. It says 39 like Mozart, of which I have counted. Notice there's 4 regions in Mozart, one of which we don't know, but I can add 13 plus 8 plus 7, which gives me 28. And so 39 minus 28 is 11. So I would need 11 more to get my total of 39 in the set of Mozart. And then I'll do the same for the next 2. Beethoven says there's 38, of which I have counted 15 plus 6 is 21. 38 minus 21 is 17. And then I would go here. It says I need to have 30 in this set of Haydn, of which I have counted 13 plus 8 plus 6. So that gives me 27. So that would leave me 3 more to get my total of 30. So the only region I haven't put anything in is here, but we know that this has to add up to be a total of 66. So if I add up all of these and then to subtract that from 66, I'll have my number that would be outside of all 3. So 11 plus 7 plus 17 plus 13 plus 8 plus 6 plus 3 is 65, which means there would have to be 1 more here. All right, so after I've constructed this, the next step would be, type the numbers in, so give me a second. I'm now doing that. 11, 7, 17, 8, 13, 6, 6, 3, and 1. All right, so those are confirmed. My math lab told me good job. All right, so I assume there's some more questions because it says A through F. So now it's going based on that Venn diagram. And kind of the pain with this problem is you got to make sure you get the Venn diagram right, and have all the numbers in there, because the questions are all going to be based off of the Venn diagram. So so make sure you get that first part right. Okay, so we're good, and now we'll go through and answer the questions that they have based on the Venn diagram. First question is, how many of these students like exactly 2 of these composers? So in answering it, since it said exactly 2, we wouldn't count these guys because they like 3. And we wouldn't count these guys because they only like 1. But this group of 7, this group of 13, and this group of 6 all like exactly 2 of the composers. So 7 plus 13 is 20, and 20 plus 6 is 26. So we should have 26, like exactly 2. Punch that in, and we're good. Go to the second question. How many of these students like exactly 1? So that would be this 11, this group of 17, and this group of 3. That would be 20, and then 20 plus 11 is 31. So there should be 31 students there. Good. All right, how many of these students like none of these composers? And there's only one, this person right here, that did not like any of the 3. Good there. All right, so, oh, nice. Should have been jotting down these numbers. That was 31, and this was 1 student didn't like any of the 3. Now to the fourth question. How many of these students like Mozart, but neither Beethoven nor Haydn? And that would be this group of 11. They liked only Mozart, but neither of the other 2. Good there. So it's a group of 11. Next question. How many of these students like Haydn and exactly 1 of the other 2? Okay, so how many of these students like Haydn? So we know these guys right here, all of them like Haydn. So that would be 13, 19. Add all those up and set H. 13 plus 8 plus 6 plus 3. All right, so there's 30 students that like Haydn. Now, and exactly 1 of the other 2. One of the other 2. All right, so so the key word here, so I want to make sure I'm reading this right. I'm punching in an answer before I give it. I want to see if I've got the right answer, and I do. Okay. All right, so this one right here is probably the trickiest one so far on E. So I want to say it one more time because the words matter here. How many of these students like Hayden, which we know anyone inside the set H likes Hayden, and exactly one of the other two. And the key word there is and. So this is as far as set operations go, this is intersection. So they have to belong to both of those sets. They have to like Hayden and they have to like exactly one of the other two. So these 13 right here like Hayden and they like also Mozart, one of the other two. This group of 6 like Hayden and one of the other two, in this case, Beethoven. So total, that's 13 plus 6 is 19. Any questions on that one? All right. So the key word there again was and. It was an intersection. All right. So the last question. How many of these students like no more than 2 of these composers? Like no more than 2 of these composers. All right. So let's see. Now, let's see if it's this easy. That's it. Okay, so again, it's this one is also, so the last 2 were a little squirrely. This one, how many of these students like no more than 2? So when I look at this Venn diagram, I'm saying, okay, to be in this set, you have to like no more than 2, but you could like just 1 and you could like none. So there's only one group of students not in that set, and that's these 8. They like all 3. So if you just take your total number, which was 66 and minus 8, that's going to give you 58 that would belong to that group. Any questions on that one? All right. Any questions on the problem in general? Are we good? All right, another problem from 2.4. Going once, going twice. Okay. Anybody else?